Here we go with the central limit theorem, example number 4. And so again, we are given the fact that there's a population that has a mean of 2,000. All right, so that would be our value for mu, right? And the standard deviation is 187.5. And this variable, by the way, is the amount of clothing that a family of 4 washes in a year, I believe. But anyway, so that's awesome. It doesn't mention anything about being normally distributed, which could be a little bit of a concern for us. We don't really know how this variable would look if we were to graph it. But here's where things take a change here. As we continue to read this, and again, you have the notes in front of you that have been uploaded, it says 50 families are randomly selected. I hope you are thinking, that sounds like a sample. That's not the entire population, that's just a sample of 50. And then it goes on to ask us, what's the probability that the mean for the 50 families, what does that mean? That's the mean of a sample. What's the symbol for the mean of a sample? X bar. We're leaving our X and jumping over to the X bar. That's important to notice that. All right, so this would be a perfect example of where we would be applying the central limit theorem, wouldn't it? The mean of a sample. All right, so as we've discussed earlier, the mean for this new distribution is always equal to the original, so that will have the same mean of 2,000. But the standard deviation for this new distribution, sigma subscript x bar, the mean of a sample, is equal to the original standard deviation divided by the square root of n. And if you remember when you read the question, it said that they sampled 50 families. So that would be the value of n for this particular situation. So 187.5 divided by the square root of 50. There's a new standard deviation in town, and it's approximately 26.5165. There's a new standard deviation in town. And that would be really important for you to recognize that. Goodbye, sigma. I jumped away from the x and went off with x bar because, again, the mean of a sample was referenced. And then the other aspect of this that you might remember would be that since they sampled more than 30, it doesn't matter how the original population was distributed. The mean of the sample, the distribution of sample means, is indeed a bell curve. And that's our justification then for finishing the question using the standard normal bell curve as a guide. All right? So we'll put that 2,000 there in the middle. That's the mean. And then we'll set up the area that's described in the question. So, what does it say back in the question? You have this in front of you. I understand it might be difficult for you to see it on the screen here. But it says, what's the probability that this is between 1,980. By the way, Mr. Sodacan was in high school that year. The mean of the sample is between 1,980 and 1,990. And again, apologies for squeezing this in. Board space is at a premium here, doing this on video. But anyway, you will note that both of those are below the mean of 2,000. So we're looking for that shaded area between 1980 and 1990. In 1990, what was I doing then? You don't want to know. All right, so anyway, we will then draw our new standard normal picture with a similar looking sliver. And the idea would be now, we have basically come full circle. Because at this point, this transitions into the kind of question that we enjoyed on assignment 17. Whereas this is assignment 18. So again, we're full circle. Oh, look out over there. Sorry, I didn't mean to hit you. Okay, so now we standardize both of these scores, which means we'll change them into z values. And you're hopefully going, oh, this is so assignment 17. We've done this before, Mr. Sock Puppet. And so anyway, you take each of these, and remember the thing we use to standardize a score is z equals x minus mu over sigma, as discussed on a previous assignment. Feel free to hit pause if you ever need to. All right. But anyway, for the 1980 1,980 minus the mean of 2,000 over the standard deviation, 26.5165. And again, all of this is justifiable in terms of a bell curve because of the fact that they sampled at least 30. So that's why we were allowed to draw this beautiful bell curve here for the rest of this question. And we will work with it accordingly from now on, Beldar. Ask your parents, maybe your grandparents, I don't know. But anyway, we've got that. So, we standardize that score. That's just arithmetic. And so that particular one, looking at my work here, is negative 0.75. And this would be this corresponding value here for 1980 on the new standardized picture. And then 1990, same thing. X minus mu. I'm really sorry, I know this is probably difficult to see because of the constraints of the frame I have here. But anyway, that one standardizes to negative 0.38. As mentioned before, if your value is below the mean, it's going to have a negative z-score, as we see here. And once we have that new picture there, awesome. Can't we go to our good friend the table, right? And table time, right? So anyway, it's table time. And let's remember that when we look up a z-score in this specific table, it gives you that good old middle sliver there. So if we go look up the 0.75, oh, this is so assignment 16. We did that a long time ago. So 0.75 makes a middle sliver of 0.2734. And that would be this middle sliver right here. 0.2734. Let me confirm that's what I found earlier. Yes, just remember table, always give middle sliver. This table, always give middle sliver. All right, then we look up the 0.38 in a similar fashion as we did on a previous assignment. And the 0.38 will create table, give middle sliver. This area here in the middle. So the 0.38 will give us an area of 0.1480. 1480. Look at the table that you have in front of you. And I would hope you would agree with me then that we would take that green, maybe the colors don't show, but this middle sliver minus that one will leave the area that we're looking for. So 0.2734 minus 0.1480 will give us the region we want, which is 0.1254. If you want to call that 12.54%, that would be totally fine with me. So once again, it was very important here to note that since we were asked to determine a probability related to the mean of a sample, that we made that jump from our x and jumped over to the x bar. All right? So let's go ahead and enjoy the rest of this one, remembering that we made that jump when it asked us to determine the probability related to the mean of a sample. Good thing that stopped. I think I broke my hip. Good luck, everybody.